Next, we want to take a look at some graphs and see if we can find from the graphs the equations that gave us those graphs. Here's our first one. This is a straight line, so a little review from algebra. I want to find the equation of this straight line. I notice that the y-intercept is 1, so I'm going to say that b is equal to 1, and then I'll just look for the slope. And I see that a run of 2 is always accompanied by a rise of 1. So the rise of 1 accompanied by a run of 2, so m will be equal to 1/2. I know the equation of any straight line can be written as y equals mx plus b, so this line must be y equals 1/2 x plus 1. And then if I wanted to, I could substitute some values of x in, get out the corresponding values of y. I'd have some ordered pairs that are solutions to this equation, and I could check to see that sure enough their graphs would lie on that line. Let's look at a trig function. Here I have a graph of a trig function. I want to know what is the equation. Well, let's just look at the characteristics of this graph. First of all, I'm going to look at the amplitude, and I see that the amplitude of this graph is 3. That tells me that a, that coefficient that I use in my trig equations, a is equal to 3. The period of this graph I know is always going to be 2 pi over that b coefficient, and in this case I see that the period is 2 pi, so that means that b must be equal to 1. So I have b is equal to 1, a is equal to 3. Now there's no phase shift, it starts right here. I'm going to say that this looks like a cosine curve that's been reflected. Whoops. So the graph is a cosine curve that's been reflected, so it's going to be y equals, I'll put a negative sign in that will reflect it. Amplitude is 3, cosine of b times x, which is just going to be x. So here's my negative sign. That reflects the graph. The amplitude is 3, and the period is going to be 2 pi divided by 1, which is just 2 pi, and of course it's a cosine curve. So this graph right here comes from this equation, y equals negative 3 cosine x. Let's look at our next one. I have this curve. It looks to me like a sine curve, so I'm going to say, well, okay, this is a sine curve. So I have a sine curve. The amplitude, I'll check it. The amplitude is 1, so that tells me that a is equal to 1, so I have that coefficient. The period here is 2 pi over 3, so the period is going to be 2 pi, always divided by that b coefficient. In this case, for this graph, it's 2 pi over 3. That tells me that b is equal to 3. Now, anything else about this curve? There's no phase shift. So my curve starts right here, a nice sine curve, starts right here, no phase shift, has an amplitude of 1, a period of 2 pi over 3. That tells me that b is equal to 3, and it hasn't been reflected, so it's pretty easy to write the equation. It's going to be y is equal to the amplitude 1 times the sine of b times x, which is going to be 3 times x. So y equal 1 sine 3x, or just y equal sine 3x would be the same thing. So here's this equation, here's this graph, and from this graph I found this equation. Let's look at our next one. This also looks like a sine curve, so I'm going to say, okay, it's a sine curve. My amplitude is 4, so that tells me that a is equal to 4. My period is 2. I know my period is always 2 pi divided by b. That comes out to be 2. Okay, I'm going to have to solve this equation. I'll multiply both sides by b and end up with, let me take it down here, 2 pi is equal to 2b. So b must be equal to pi. I see I don't have any phase shift. The phase shift is 0. It's a sine curve that has not been reflected, so I can write the equation pretty easily as y is equal to, let's see, my coefficient a, 4 sine, my coefficient b, which is pi, times x. And sure enough, if I was to try to graph this equation, I'd say, well, it's a sine curve. It has an amplitude of 4, and it has a period of 2 pi divided by pi, which is the same as 2. So I see that this graph does have a period of 2, and that will come out of this equation. So here again, I've taken the graph of an equation, and from that graph found the equation itself.